Welcome back to the class on electrical machines. In this lecture, we are going to solve the 5 numericals based upon the EMF equation of synchronous generator. Let me take up the first numerical. The coil span of stator winding of alternator is 120 degrees. Find the chording factor of a winding or pitch factor. The chorded angle alpha equal to 180 degrees minus 120 degrees, that is equal to 60 degrees. So the chording factor Kc equal to cos alpha by 2, this is equal to cos 60 degrees by 2, we are getting the 0.866. Calculate the distribution factor for 36 slot 4 pole single layer 3 phase winding of an alternator. So first of all, you have to calculate the number of slots per pole. 36 by 4 gives the 9 slots per pole. Next, number of slots per pole for phase, that is small q. This is equal to capital Q by 3. We are getting the 3. Slot angle. The slot angle gamma equal to 180 degrees by number of slots per pole. Now you have to take this value here. We are getting the 20 degrees. The distribution factor Kd equal to sin Q gamma by 2 divided by Q into sin gamma by 2, where small q is nothing but a number of slots per pole for phase. This value, substitute all the values, we are getting the 0.96. An 8 pole 3 phase double layer winding has 72 coils in a 72 slots. The coil is short pitched by 2 slots. Calculate the winding factor for fundamental and third harmonic. In this numerical, it is given that 8 pole 72 slots. The coil is short pitched by 2 slots. So if you find the value of slot angle, that you have to multiply with 2, that gives the chorded angle alpha. The number of slots per pole capital Q equal to total number of slots by number of poles, that is equal to 72 by 8, we are getting the 9. Number of slots per pole per phase, small q equal to this value divided by the 3, we are getting the 3. Slot angle gamma equal to 180 degrees by number of slots per pole, we are getting the 20 degrees. So chorded angle equal to 2 into gamma, because the coil is short pitched by 2 slots. So alpha equal to 40 degrees. So first we are finding the pitch factor and distribution factor for the fundamental component. The chorded factor Kc1 equal to cos alpha by 2, that is equal to cos 40 degrees by 2 equal to 0.94. Distribution factor Kd1 equal to sin Q gamma by 2 divided by Q sin gamma by 2. We know all the values, substitute here, we are getting the 0.96. So the winding factor for the fundamental compound equal to pitch factor or chorded factor into distribution factor for the fundamental compound, we are getting the 9. Third harmonic. We know the formula for a third harmonic. We know the formula for the pitch factor or chorded factor. Kc3 equal to cos n alpha by 2. See here it is a third harmonic, so n value becomes a 3. Substitute all the values, we are getting the 0.5. The same manner, the distribution factor for the third harmonic, that is denoted by Kd3, that is equal to sin n q gamma by 2 divided by q into sin n gamma by 2. Substitute all the values, we are getting the 0.66. Now the winding factor for the third harmonic equal to pitch factor for the third harmonic into distribution factor for the third harmonic, we are getting the 0.33. A 3 phase 8 pole 750 rpm star connected alternator has 72 slots on alternator. Each slot has 12 conductors. The winding is chorded or short pitched by 2 slots. Find the induced EMF between the lines, and given flux for pole is 0.06 Webers. First we are finding the number of slots per pole, that is capital Q equal to 72 by 8, that is equal to, we are getting the 9. Next, number of slots per pole per phase, small q equal to capital Q by 3, we are getting the 3. Next we find the slot angle gamma equal to 180 degrees divided by number of slots per pole, we are getting the 20 degrees. Chorded angle alpha equal to, because in the numerical it is given that the coil is chorded by 2 slots. So the chorded angle alpha equal to 2 into gamma, we are getting the 40 degrees. The chorded factor, nothing but pitch factor, Kc equal to cos alpha by 2. Substitute all the values, we are getting the 0.94. The distribution factor Kd equal to sin q gamma by 2 divided by q into sin gamma by 2. Substitute all the values, we are getting the 0.96. The binding factor Kw equal to Kc into Kd, this value we are getting the 0.9. Now we have to find out the EMF induced between the lines. EMF equation is consisting of frequency, but in this numerical the frequency is not given, but the speed of alternator is given. So the synchronous speed ns equal to 120 f by p. So from this expression we can find out the f equal to 750 into 8 by 120, where 750 is nothing but a speed of a alternator. We are getting the 50 Hz. The flux per pole is given, that is 0.06 Webers. Next, we have to calculate the number of turns per phase. Number of turns per phase equal to total number of conductors divided by 2. But this total number of conductors in an alternator is not given directly. 72 slots, each slot is consisting of 12 conductors. So 72 into 12 divided by 2, we are getting the 288 turns. The per phase EMF induced equal to 4.44 kW F pi T. Substitute all the values. We have a 4.44 into 0.9 into 50 into 0.06. Nothing but a flux. 288. Nothing but a number of turns per phase. If you multiply this value, we are getting the phase voltage. But in this numerical, they ask you to find out how much is the line voltage. Here, the alternator is connected in a star, so the line voltage is equal to root 3 times the phase voltage. So line voltage is equal to root 3 into the same expression we have taken here. So finally we are getting the value 2998 volts. Fifth numerical. Calculate the RMS value of induced voltage per phase of a 10 pole 3 phase 50 Hz alternator with 2 slots per pole per phase and 4 conductors per slot in a 2 layer. The coil span is given 150. The flux per pole has a fundamental component of 0.12 Webers and 20% for third harmonic. First we are finding the number of slots per pole per phase, small q. This value is directly given in the numerical, that is 2. Next we are finding the number of slots per pole. So this we have to multiply with a 3. So we are getting the 6. Now slot angle equal to 180 degrees divided by number of slots per pole, we are getting the 20 degrees. So the chorded angle equal to 180 degrees minus 150 degrees, we are getting the 30 degrees. Because the coil span is given in 150, the full pitched coil is 180 degrees. So 180 minus 150, that gives the how much angle the coil is short pitched. That is alpha equal 30 degrees. The total number of conductors equal to 4 into 2 into 10. See, this is the number of slots per pole per phase. This we have to multiply with a number of poles, that is 10 poles. So it gives the number of slots per phase. That we have to multiply with a number of conductors per slot, that is 4. We are getting the 80. Number of turns per phase equal to conductors divided by 2. We are getting the turns, that is 40. Now we are going to find out the how much is the fundamental voltage induced in a winding. The chorded factor for the fundamental value Kc1 equal to cos alpha by 2. This is equal to cos 30 degrees by 2. We are getting the 0.96. The same manner we know the formula for the distribution factor Kd1 equal to sin q gamma by 2 divided by q sin gamma by 2. Substitute all the values, we are getting the 0.96. So the winding factor for the fundamental component, that is equal to Kc1 into Kcd1, that is equal to 0.966 into 0.966. We are getting the value 0.933. So the per phase voltage in a stator winding due to the fundamental component, that is equal to 4.44 kW1 F1 pi 1 T. All the values are given. kW1 is nothing but 0.933. F1 is nothing but 50 Hz. Pi 1 is nothing but a fundamental flux, that is 0.12. T is nothing but a total number of turns per phase, that is 40. We are getting the 994.4 volts. This voltage is nothing but a fundamental voltage. Next we are going to find out the third harmonic voltage induced in the stator winding. The coordinate factor for the third harmonic Kc3 equal to cos n alpha by 2, where n equal to 3. Now you substitute all the values, you are getting the 0.707. The distribution factor for the third harmonic Kd3 equal to sin Qn alpha by 2 divided by Q sin n gamma by 2. This is equal to, substitute all the values, we are getting the 0.707. Now the winding factor equal to Kw3 equal to Kc3 into Kd3. Substitute these two values, we are getting the 0.4998. Third harmonic flux is nothing but it is equal to 1 by 3 times the fundamental flux, but in the numerical it is given that 20% of the flux we have to consider. So pi 1 is a fundamental flux divided by 3. This is the third harmonic flux into 20 by 100. Finally, you are getting the 0.08 vapors. The frequency of third harmonic F3 equal to 3 times the fundamental. So we are getting the 150 Hz. The per phase induced voltage in a stator winding due to the third harmonic flux, that is equal to 4.44 kW3 F3 Q3 T. Substitute all the values. Finally, you are getting the 106.56 volts. Now the total voltage induced in a stator winding, that is equal to square root of E1 square plus E3 square. Already we calculated the value of E1 square and E3 square value, this one. Substitute here, we are getting the 1000 volts. Thank you very much. If you have any doubt, you can ask me directly or you can ask in the comment box of my YouTube channel, so that I am always welcome to answer all your questions.